All right, hello everyone. Yeah, let's see if all the systems are up and running. We are back with another stream today. It's been a week since the last stream. I actually wanted to stream yesterday, but that didn't work out. So hello everyone. Today from a different position in the shop because we will be doing some KiCad design stuff, less Microsoft assembly related stuff today. So nice to see you all. I hope you are having a nice Friday or whatever day it is where you are. Yeah, anyways, I think we are getting people into the chats and into the channels. I know that there are other streams also running. I think Micah is currently also streaming, which is pretty awesome. That's why I didn't stream actually yesterday, even though I was planning to, because Micah is doing some very interesting reverse engineering of a voting machine, of its interface. So basically of the whole computer system. It's like a 486 computer, and she was doing some reverse engineering of how the boot up process works, and she hooked up a logic analyzer to the SD card interface. No, not SD card. It's an IDE card. Oh, I'm forgetting. Flash card. Anyways. And trying to reverse engineer what is going on there, because it was a little bit proprietary. So I got sucked into that because it involved Sigrok. Oh, hello Vince, nice to have you here. And yeah, you should get some dinner and some snacks. I thought that was very interesting. We learned quite a lot about the usability of Sigrok, and we were improving some of the software, or like making notes as she was going through the whole process of writing a IDE protocol parser or protocol decoder for Sigrok, and that was very interesting. So I hope you were watching too. Today's stream will be somewhat apropos because it's also involving Sigrok, but we will be making progress on some logic analyzer hardware for Sigrok. As you might remember, we kicked off this whole streaming like endeavor quite a while ago, last year, with making a version of Uwe's tiny fx2grok tiny board. So I have some of his old prototypes here, and these boards have a 10-pin connector and have the FX2 chip on it. I never assembled these because they have a mistake where the footprint of the FX2, I think, is flipped or something, so that never worked. I did not end up ordering a new set of boards for this, but Uwe was assembling working ones and giving them out at CCC, which was pretty awesome. Several people got those. So that was the kickoff of the whole stream, and I made a so this version of the board has parts on both sides of the board. I wanted to make something that is a bit easier to put together, maybe a little bit more practical, let's say, because Uwe's motivation was mostly a fun project to make something very small as possible. So I made this board. There we go. That's the fx2grok 0.2 flat, and that board has a little bit front-end protection, has the same chip, mostly the same circuit. It has, yeah, it's very close to the original, but has a few added things. I also used the same cable and connector as Uwe did. He was mounting it on the edge of the board, just like we did last week with the FTDI adapter board. So from last week, you remember these FTDI boards? Yeah, so this is how it looked like. I finished assembling those, I think off stream. We assembled the board, we did some testing, but I did more assembly and testing off stream. I put those together and sent them out to Clifford and Dave. Yeah. Yeah, these boards seem to be working. I used that opportunity to actually learn a little bit of how to use Vivaro. It was pretty interesting to have the FPGA board from Xilinx run a full it completely went off the rails because I wanted to just test these boards and wanted to just use UART and stuff. So I thought, oh yeah, it's a good opportunity to play around with an FPGA. So, and then I ended up designing a microblaze based soft core, and then ended up running Linux on it. So it's like the Artix boards with the Xilinx Artix 7, so RT board. They are pretty amazing. You can, using Vivado, you can, in a short time frame, synthesize a complete Linux-capable computer and also compile a Linux distribution dedicated for that hardware that you just made, which is completely ridiculous. And Vivado and its built-in SDK make at least that part very easy. I know that this kind of software packages, they make the first step of making a complex system, put together a complex system very quick and easy as a demo. And then when you actually want to make modification to all of this stuff, everything falls apart. That's my expectation, at least. But this was still incredibly impressive that you can run a Linux distribution on the RT Xilinx FPGA. Yeah, because it has like DDR3 RAM and a lot of flash on board. Anyways, so that's the tangent story that I ended up going into when I wanted to just test an FTDI adapter. Anyways, that happens sometimes. But it worked, so I put this together. I posted on Twitter, if you check my Twitter, photo of the whole kit of parts. It was 19 boards or something. Different adapters, the FTDI boards, and the 2 different FPGA boards based on the ICE40 chip. All right, so yeah, we were working on this fx2grok board. I did not come around to do an additional round on the prototype boards yet. So since I think December, we assembled these boards. So we tested it. It seemed to be working. And then I went to CCC. And so this is the cable that it comes with. I even made this like marked flywires to use it easily. And I was showing it off and discussing it with the guys from the Sigrok project. And let me check. So Abraxa mentioned that it would be a good idea to make the connector more compatible with Uwe's connector, as well as some other people. I think it was Micah and someone else on Twitter mentioned that we should bring out the IF clock pin out of this board. So the IF clock is the clock used to to drive the GPIO sampling that is then going into the USB bus. So what you can do is, instead of self-clocking at a certain rate and read out data like a logic analyzer, you can clock it from the outside and give it an exact time to sample the data and send out over USB if it is correctly configured. And if we bring that pin out, that will be quite a useful improvement. This is pretty much the main thing that we want to do on the board. I don't think we have much more like circuit-related changes to do. The only other thing is, so we could theoretically bring out more of the GPIO out, so up to 16. It's not very fast. It's even at the 8-bit that we currently have. The logic analyzer is useful for only very like slow and simple communications. So just the FX2 chip with no FPGA to stream to serialize the data, because it can only sample 8 bits and you cannot sample just 1 bit and shift it into the USB interface. So 25 megahertz is pretty much the maximum you can do. And for example, if you want to use that logic analyzer to read out a USB interface, for example, it is not fast enough. To sample USB, you need at least 50 megahertz sampling rate, if not more, to get reasonable data about the USB interface at full speed, not high speed even. So that is something I ran into just recently when I was trying to debug the Icebreaker BitC boards with the tiny FPGA bootloader. So anyways, that would be a good reason to actually put an FPGA in front of the fx2grok flat, but let's not make it more complicated than it already is. I currently pretty much want to drop in an FPGA into every project I currently do. So yeah, it's it becomes quite a futurism thing. Anyway, so let's see what we have so far. So this is the board. So I copied the project, the 0.2, and we will continue making the changes we want. And we have 3 to-dos today. One is IF clock, then change the connector. So this is something I was not very happy with. So let me go back to the camera here. So as you see, we are using this Samtec connector. That is quite nice in a sense. Come on, focus. You can do it. So there is the connector. And what we want to do, so I don't like the fact that it is right angle, so it is hanging out like this. I would prefer if I use a USB cable. Let me pull one out here. I plug it in here, and I want this stuff to be in line like this. So we have to figure something out. Either use the same series of connectors and find a right angle version of it and continue using that, or we have to use something else. I don't really have a good solution yet, and we will discuss this here on stream. We will go through a few options. Maybe someone of you in the community will have a good suggestion what we could do. But either we use the same connector and have a right angle, or we put it on the edge of the PCB, which I don't like very much because it's not very good for production. As I discussed last time, having a connector like this on the edge of the PCB means we cannot reflow it, because we would need solder paste on both sides of the PCB, and we can't do that easily we want to put the solder paste only on one side of the board, put the parts on, put it in the oven, and maybe flip it around. If you have a connector that has that requires solder paste on both sides of the board, you need like some complicated jig to make that happen. That's completely out of the question. We are not doing that. It's nice if you do one-off in a hobby setting, but if you want to do production, that's not an option. So, for example, this solution for this problem here will carry over to the problem we have currently with the FTDI boards, because they have exactly the same problem. Unless we basically say we sell these boards with no connector attached and the user has to solder it on manually themselves, we can do that. We cannot do that here and basically sit someone down with a soldering iron and solder all those boards by hand. And that's economically completely impossible. It makes it very expensive. No one would want to pay the amount we would have to charge for someone to sit and do that by hand. Okay, so we have to solve this, and first of all, let's do the simple stuff and just add the IF clock connection, and then we can look into the connector situation. All right. I'm sorry, I'm having quite a frog today in my throat, and I don't know. Let me try to mitigate the situation. All right. So this is the schematic. Then we have the board, and I already placed a few candidates for connectors here, but we will discuss it later. So first of all, the IF clock connection is this pin here. It's on pin 13. Then we have clock out on pin 54. And there's several issues that we run into having to bring them out. So currently, if you look at the connector, this connector is quite nice. We have 8 so 1, 2, 3, 4, 5 connections, so it is 10 pins that we have brought out. So we have 1, 2, oh, we do have spares. Oh, good. I did not, okay, so we do have the spares. Okay, sorry. Let me explain. We currently use these ESD and frequency cutoff filters on all the pins connected to this connector. And the chips we are using have 4 units in it. So each package, if we highlight this, so I'm already in the nightly build of KiCad, so we can highlight stuff here nicely. So this is already highlighted, as you see. So this thing has 4 units that you can pass through the part, making it very nice to have the signals connected. And this part here only uses 2 of them, so we still have a spare in here, so we don't need to add an additional part. I was concerned that we will have to add an additional part to get those signals also through that filter, but we don't, so that's good. The other thing is, so what Abraxa also mentioned is that we should be more compatible with the connector that Uwe made. So let's look. Is there a pinout already mentioned on the page here? Yeah, there's a schematic, I think. Let's do this way. So if this is Uwe's board. So this is Uwe's board, and it has ground and then 4 pins. So it is PB7, 6, 5, 4, 3, 2, 1, 0. Okay, so we want to make our connector mostly compatible with this, and just add the new signals that are not what Uwe has on the other side of the ground. I think that's the easiest thing, because then it is close to the ground but not interfering with the pinout that we have in the original. So we could theoretically put a connector in there, although knowing how these connectors are made, they usually, so in the case of this connector, it might work if you cut off the knob that is keying it, but more often than not, the ribbon cables that are compatible with these connectors, they are very wide on the side. Let me see if I can show you. Yeah, there we go. So like this. Yeah, so this connector, yeah, I would have to make a photo of this, but basically the edge on the side here is wider than just, it would not fit between two pins. So if you have pins right here in this direction, you still wouldn't be able to plug it in because it would interfere with those pins because they are wider than they should be. They use that side to have a key for this retention clip that goes on the back of the ribbon cable. So anyways, it's not an ideal solution, but yeah. Anyways, we will keep at that. We will try to keep it compatible because then we can at least solder on a connector that would be compatible. Anyways, doesn't matter. Let's do that. So we will go here. First of all, we have to make we have to move the trigger and the clock pins. So we will move this guy to the bottom like that. Then we can move the ground like this, then it is compatible. And then we can connect these, and we will make some more space here. It's like nice and organized, but it's in the way, like this. Let's make more space here. Like this. Yeah, there we go. Yeah, that's better. Just con. You don't need this really long name there. There's no need for that. Yeah. Don't do that. No. Okay, let's make it longer. There we go. So trigger, clock. This, and then for consistency reasons, let's do this. There we go. Okay, so now we have it compatible with the connector that Uwe has. And now we wanted to add the IF clock. So the question is, do we want to also get the clock out? I did not exactly check what the functionality of clock out is. Let's pull up the data sheet for the FX2. FX2, so let's go on the FX2, not Cypress. No, not breakout board. We want the data sheet. There are two PDFs for this. I don't remember exactly which one of the two had the documentation for those pins. So IF clock, let's look for that first. IF clock. Because one of the, and then clock out. So I think one is a monitoring, but as far, the data sheet was pretty clear that the IF clock can be also used as a clock output. So let's see if we can find interface clock, used synchronously clocking data into or out of the slave FIFO. IF clock also serves as a timing reference for all the slave FIFO control signals and GPAF. When the internal clocking is used, ifconfig, the IF clock can be configured to output 30/48 MHz by bits ifconfig 5 and ifconfig 6. IF clock may be inverted whether internally or externally sourced by ifconfig 4. And then let's see, does this thing also have the clock out? Because it might be useful. Because we have one spare pin too that we could also bring out. PD, PD, PB, PB, clock out. Clock out 12, 24, 48 MHz clock, phase locked to the 24 MHz input clock. The 8051 defaults to 12 MHz operation. The 8051 may 3 states this output. So this seems like a clock out of the 8051 inside the chip. It's not related to the USB interface. Interesting. So one is for the USB interface and the USB engine, and the other one is an internal 8051 clock. So I don't think we need that exposed here, unless unless someone tells me otherwise. So let's just remove the no connect, connect a wire, and name it IF clock, and add this here. Oh, what's going on here? 60? Why is this so tiny? There we go, that's much better. Then we have to add one more here. So this is unit C, this is unit A, and we have to add one more unit. So let's extend this. Like 6 or something. Yeah, that sounds about right. Six. Copy. One, two, three, four, five, six. Look at this. Let's copy ground, attach ground. Okay, just checking if there's any chats that I'm missing. Yeah, So yeah, Vince was mentioning that it's a common problem of flipping stuff around. Yeah, I know. Oh, now I remember exactly what happened. So Uwe had the order of pins on the part in reverse. So it was, instead of 1, 2, 3, 4, 5, it was 52, 51, 50, 49, 48. And it's like basically it was in the reverse direction. It's yeah, that happens. Label, and this should be X, so external. What happened here? Why is this move? Let's move this here. Let's move this here. Move. Oh. All right, so that's good. Now we have to add the IF clock here. So we need a connector that has more pins. So we add from 2 to 7. So this would be, we would need to change, but we need to change the footprint anyways. So let's move this guy. Let's move the label, because it is label, I said, field reference there. And we can add, which way do we want it? PB0, PB1. Yeah, 0, 1, 0, 1, 0, 1 is, so this is the outside edge part, so let's do this side. And we can put a no connect on here and keep it reserved for future use, just in case we decide to put another signal on that connector. Yeah, let's name it. It's weird how that is defaulting to this. Okay, and we can copy, not trigger, but it is IF clock. And this is the IF clock X, and we have it connected. Good. So that's done. One of the fun parts will be to actually route it out, because the IF clock pin is on pin, what did we say? On pin 13. Pin 13 is here. So we will have to bring it out and go all the way up to the top side. And also we have to move these and swap them around with the ground and convert them. Oh yeah, yeah. So we will have some fun there. Anyways, so the most basic change is made now. We have that additional signal brought out. Do we want a pull-up on this? I don't think we do, because we have pull-ups on these. That is useful. What did we do with the trigger pin? Trigger is here, it has a pull-up. And then we have clock that we connected where? Clock is here. It does not have a pull-up. I think it should be fine though. Okay, so that's good. My phone is vibrating. Let's check. Nothing important. Good. So yeah, I think we have to look into the connector situation now. So we need a 14-pin connector. One thing I was hoping to use is something that is the same type of connector. So I have several requirements for it. So it has to be a 0.05 inch pitch, meaning a 1.27 millimeter pitch connector, 2-row, because they are reasonably common. I would like not to have to make the board wider than it already is. I would like to be able to make a wire harness that has fly wires, just like here. So this is how this looks currently. This is what I made here. I want this thing to be right angle, so lay flat on the PCB. I want it not to be too expensive, so I would rather not use a Samtec part because Samtec connectors are expensive, and even with like high volume pricing, they're still like at least basically a magnitude more expensive than some cheapo Chinese thing. Yeah, that's my requirement list. It's I spent quite a lot of time trying to figure out what the options are, and we can look at first of all at the simple solution, namely using Samtec, and what they have available. The alternative to all that is also break the rules that I just said and use a different connector. So the thing I put here on the board was, after being quite frustrated not being able to find something useful, I put a connector that I use quite a lot. It's the Molex Pico blade. I know I can order wire harnesses for these very easily from China, because I do that already for the wire connectors on, let's see, yeah, there we go. So this kind of connection, so you have the, come on, you can do it. So you have this Molex Pico blade, and then you have discrete wires coming out of that, and then on the other end you either have a connector that you can crimp on this, or you have this heat-shrinked tubing on there, and you can have the clippers on that. I like that. The nice thing, so the differentiating factor that I want to retain on this board is being able to keep it in my toolbox. I don't want to make it like this. So this is huge box, mostly full of air. You will not lose it, but it's massive. So if you look at this, it is not, this one I can fit in my wallet and have it with me basically. And this one, not. This one has 16 channels, to be fair, but I want something small, easy, pocketable that I can always have with me in my backpack and not even think about the fact that it is in there until I need it. So that's the goal of the design here. So Molex Pico blade would be a solution. I used them a lot in the past. I know where to get them reasonably cheap, and we can make wire harnesses for it. The problem with that is, though, that if you look at on here, the connector is wider than the current PCB. We would have to add some width. It's not end of the world because it's not that much either, and we only need 12 pins if we do it in a single row connector. These are 8 data pins, then clock, trigger, ground, and the new IF clock. So it is 8, 9, 10, 11, 12. The alternative, so I was also going through the library that KiCad or KiCad has, and we can go through here and try to find 12-pin connectors or dual row connectors. And one of the connectors I found was the Hirosa FH12. I have no idea how this part actually looks like, so let's look at this on DigiKey hopefully or something. Hirosa FH12. How does this look like? It's like very fine pitch connector. Oh no, forget it. That's a ribbon cable. No, not happening. Okay, bye. So yeah, let's look at Samtec again. So Samtec has a selection here, search by picture. Then let me do, which one is it? Micro rugged. No, it's flexible stacking. The search is not perfect here because so this is 2 millimeter, 1 millimeter. I want these here. And now I want interconnects 1.27. And then if I open this up, I think the only option that I found, so we have either this FSH, which is a super funky, weird connector with the shrouds on the edge, which is nice. I would like a connector that has some shrouding, because if you look at the at this connector that I used on the FTDI board, you can basically plug it in like totally wrong. It's like you can plug it in like this, one row off, not all the pins, and short some stuff out and burn it up or whatever, like put power on some pin that you don't want it to be on. So it's bad. I don't like that. People are making a lot of mistakes when they're just fumbling around with stuff. So the less options you have to fumble something to burn it up, the better. So having the shroud would prevent that and make it better. So this is not bad. So this is called FSH Connector. And if we go on here, is we can choose how many pins. We want 7 pins per row. And then double horizontal. The only issue I have with this guy, solder locks? What happens if I do this? Yeah, it has pins that located on the PCB. This is not bad. It's quite a nice connector, because then you have the location on the board so that the board will, so this will not rip out. It will be always like registered properly on the board. This is not bad. Non-standard option. You would have to contact Samtec. That's not a problem. So 7 pins. 1, 2, 3, 4, 5, 6, 7. Oh, so they are leaving out 4 pins on the edges. That's an interesting solution. And what is the counterpart for these? A tiger eye. Oh, there are more? No. The only mating connector is the SFMH. Interesting. But we need a wire connector for this. So yeah, that's not working. I probably should send an email to Samtec and ask them, because they can build a lot of custom stuff, and ask them what that would be. But we should check how ridiculously expensive that thing is. Let's see. If I submit it, will it show me? 500 pieces required for non-standard connections. Interesting. So we would have to get 500 of them before we can use these. We can probably get samples, obviously, for prototyping purposes, but if we want to order them, we have to get 500 of them. But I would like to know what the pricing on that is. Yeah, and tape and reel, so that we can put it into the pick and place machine. How does that look? Yeah, well, it's pretty much you're picking it up here on the flat surface in the back to place it on the PCB. So I guess, so the biggest problem now is this looks nice. I like that. Let's look at other. So FTSH has is also an option, but FTSH, if we go through the settings, 7-pin connector, we want a double horizontal surface mount, and how does this look? Like this. There's we can have alignment pins, but we cannot have a shroud. So this one would be nice too, but we cannot have the keying shroud just like we do on the Blackmagic probe connector. So if I show you this, all this, yeah. So this is the connector here. So this one has a keying shroud around it, but it is vertical. The horizontal version does not have the option for a keying shroud. So no. But yeah, so that's the option number 2. Then option number 3, I think there was a third one. Yeah, so let's look at the TFCs. So this is what we currently have, I think. TFM or TFC. Seven pins, and we have to see if they have a right angle option of this. Yeah, I don't think they do. Locking clips, nope. What about the TFM? Single row, double row, number of positioned, lead style, tail option, right angle. What does that mean? Yeah, so this is right angle. Double horizontal, it's a non-standard option. Interesting. Yeah, they do have these. Oh, that looks funky. That is very funky. It's a non-standard option, but it exists. Oh, double horizontal. So that would be the current one, just in an SMD with locking pins sideways option. Cool. And then there should be, yeah, and we can have the wires. You know what? I think this is not bad. The only problem with all that is it's Samtec. So that won't be cheap to do. But it would be neat. Yeah, should we go neat or should we go cheap? That's the question. I think I will go neat because that's an exciting solution here. I like that. And then we can make custom connections like this with the fly wires. This is nice. So besides all this, so this is I think I will design that in. That's a good option. The alternative is completely using off-the-shelf parts is go the way. Yeah, Samtec. So Vince is confirming Samtec makes great connectors. Yes, they do. I really like their connectors. Yeah, I wish they were like half the price from the get-go. It's like half the price, then they would be competitive with the Chinese solutions. Yeah, I met with one of the sales reps from Samtec, and they told me that most of their business is actually making custom connectors. So if something is not listed on the website, you should definitely contact them via email and talk to them, because more stuff is not on their website than there is. So if you need some custom weird connector, you should contact them. They probably can make it for you. And they also can make it in smaller quantities, because they build the whole company based on automating and building machines that are custom to make connectors. So Samtec has all like custom machines to make all different types of connectors and moldings that they can rig really quickly to make a batch of a certain custom connector. And that's their main business, is making weird custom stuff. So the website is already very flexible and easy to find stuff. It's like if you ever tried to look for, I tried to look yesterday for similar connectors on the TU website. It's a complete nightmare. You can't find anything. The search is based on industry target. It's like, how do I care for what industry this connector is made for? I care about the connector that I'm looking for of a certain mechanical requirements. The only mechanical requirement was the pitch of the connections on there. Like, TE, what are you doing? This is not what I care about. It's like, oh yeah, it's for agriculture. Yeah, great. What does that mean? What is, like, who cares? Yeah, it really was obnoxious. Then this similar thing with Molex. Molex has a little bit better search. At least they are categorizing this stuff reasonably, but it's still not very good search. So yeah, in the Samtec website, it's not the fastest, but it's definitely the most easy way of finding the connector you're looking for compared to anyone I've tried so far. Oh, JST is probably the worst example you can bring up. It's like, go on their search. It's someone built that website in like mid-90s and never updated it. It's just a big database of numbers of connectors. It's like, if you don't know the product number of the connector you're looking for, you forget it. You will not find what you're looking for, because there is no search of types, anything. Yeah. Anyways, connector search is still stuck in the Middle Ages. You probably need a sales rep from all those companies and sit down with them, each one with them, and basically, I want a connector. Give me a quote for this random connector I need. Such a waste of effort. Anyways. I ramble on. But anyways, Samtec is doing that right. So even though they are expensive, I end up buying stuff from them because their website is the best and the search is the easiest. Anyways. Okay. So let's look into the alternative solution that I was thinking about. If we look at a logic analyzer, a Chinese logic analyzer, they make this kind of a connector. So if you look at the connector, it's basically a PCB that has an SMD connector on it, and then the wires are soldered to that board. This is not something I really want to engage in and do it myself, but we might be able to do this. I don't think we need this for the simple fx2grok, but we will definitely look into that when we make the faster, more complex BitMagic logic analyzer with tracing, like ARM tracing stuff. So we will definitely look into this, because if you look into here, it has impedance matching components on the wire. So this is one of those cables. At CCC, we tore it down and opened it up and measured it out, which is nice. And the other cable is this one, and it directly connects to a coax cable. So it solders here on the side to the outer sleeve, and then each signal is connected to the inner conductor, and then there is every second pin is ground connected to the PCB on the back, and within the cable at the end where it splits apart to go to ground and signal connections, that you have the matching circuitry, which is quite nice. So for higher speed stuff, not 25 megahertz, we don't need that there. But we definitely will look into this when we do the higher speed stuff. But if we can figure out that this is a cheaper solution to actually have a PCB and solder on these wires and order the whole thing put together somewhere from a wire harness manufacturer in China, then that might be actually the solution for this simpler one too. I will have to pretty much send out for a quote to know how that works. So this is using off-the-shelf parts mostly with the custom PCB with quite a lot of manual labor of soldering stuff on. So I don't know where the price difference looks like. So one thing that I like about these connectors is that they utilize the way they are put together to do the keying. I'm not sure there is an edge photo of the device, but what is happening here is the PCB on the back of the connector is keying into a cutout into the case of the logic analyzer. I don't really want to make like aluminum milled cases for the logic analyzers. Making cases and CNCing stuff or injection molding stuff is a huge pain in the ass, and I would like to prevent having to do this. So what I was thinking, if I can find this, let's see. I have some connectors. Yes, so I have these connectors that I got. This is a 50-pin connector. I don't even remember how much it costed. It was like $2 probably. You get this connector, then you solder it into the PCB. And what I was thinking of doing is the PCB itself have notches where the lower PCB that the connector is soldered on, so the connector goes into this and the PCB just slots, it's like this, so slots in underneath this connector where there are cutouts in the actual circuit PCB. So this notches in here. And on the top, to prevent it from being plugged in upside down, we basically glue on a strip of PCB. So that would be a solution. This is much more hands-on, and again, we are going down the road of a lot of manual labor per board to actually make that happen. So yeah, you see my conundrum on this. I like the idea. The problem is that we would have to probably make them and assemble them somewhere where the hourly wage is low enough to make that reasonable. So yeah, for prototype purposes, I think we should just go with the Samtec connector for now and make the next revision of the board using the Samtec connector. I probably should make a to-do item of reaching out to my wire harness manufacturer and ask them if they can make these cables that have a PCB inside. So basically, if they can make this assembly for me as a part of a wire harness. If they can, then yeah, then I need to know what the pricing on that is, and then we will figure it out. What I already figured out is that this kind of connectors, so where you have the half-pitch connector with single strand wires in it, yes, they can do that, they said. Also, I found a I think it was a Taiwanese company making half-pitch connectors that fit onto a normal pin header that are not just crimped ribbon cables, but actually crimped single discrete wires. So that's good. So there is a path down that road. All right, so because I'm sure we can get this part, let's see. So we want 7 pin, yes, 7 pins. Let's get a free sample. Will that open? Get a free sample. And how many do we want? We want 10, then I can fill this stuff in and get that ordered, I think. Is that this? No. Let's go back. I don't want to lose the 3D model for now, because I actually need, before I place the order, oh, come on. Please, go back. I need to download the footprint. PCB footprints, pads, I don't want... They have Eagle, ASCII, Altium, Allegro. Where is KiCad? I want a KiCad download. Samtec! Where is KiCad when you need it? Anyways, yeah, I will draw the footprint, it's fine. Pads. I want a PDF for the footprints. Footprints, there we go. Surface mount footprint, double row vertical, double row horizontal mount, surface mount TFM, there we go. And it has all the things. Okay, cool. We will make the footprint for this then. But first, I need to scoot out for a sec. Be right back. Let me mute you. All right, there we are. Okay, so we have this guy. Let's see. What is the difference here? So one of them is SMD retention, and the other one has the through-hole things. And I think I want the through-hole pins. Yes, I like that. Let me move this to the other monitor. And yeah, so we got rid of the idea of using the Pico blade wires for now, even though that might be even the easiest one. But let's use this nice Samtec connector instead. So what I need to do is create a new footprint. And let's see, library, we need Samtec, PKL, Samtec. And then we create a new footprint and we call it TFM. What is the naming? Let's see, TFM. I have to click it together again. So 7 pins. We want a double row horizontal. And we want generate. Let's see how that looks. Yes, that looks about right. So TFM dash 107 dash 02 dash L dash DH, because this is selective gold. I don't really care. So this would be X, but double horizontal is important. Lead style is fixed. You cannot have something different. 1007, that's correct. Okay, new footprint, there we go. Then let's go to here, the pads. So these are SMT pads. Let's go to something more reasonable. There we go. And the pad is an SMD pad. It is rectangular. Yeah, I want to switch my whole library to the round rect. It's like rounded rectangle like this, like you see. It's like I like the rounded rectangle solution. But let's keep it consistent for now, and I can switch over everything at some point. Each pad is 0.74 wide and 1.14 high. 1.14 high. Yes? Yes. And they are staggered. Front copper. Okay. Whoa, that's large. Oh, we are in inches. Jesus. Okay, that was crazy. Okay, 0.74. I wanted it in millimeters. 1.14. There we go. That's better. Now, this should be saved. Yep. And the pitch is 0.05 in this. 0.05? Yeah, 0.05 in one direction, and then in the other, what is the distance? They show it? No, they don't. They do not. But what we can do is do this, and they say it is offset from, so 0 is supposedly on one of the mounting holes. So let me bring this back here. So if you look here, so what I'm looking at is I'm trying to get the distance between those pads here, and all they give you, this is a very typical thing that I'm complaining, like getting very angry about regularly, is the way the distances are shown on those drawings are completely useless if you're making footprints. What you care about are distances between features. And they give you like one reference feature and all the distances are from there. But I want the distance between these two. I don't want the distance from the hole here. It's annoying. Anyways, we could theoretically just offset everything and move it 5.11, and yeah, we can do that. But we need to create an array of those. Array of those two. So think. Yeah, so position y of this would be 5.11 minus 5.11, and this guy goes 6.63 minus 6.63. Oh, this is the wrong way. Yeah, I went the wrong direction. Okay, so it has to go the other way around and the other way around. Okay, so this is offsetting this direction. And then create an array, and we want horizontal count should be 7, vertical count should be 1, horizontal spacing is 1.27 millimeters, vertical spacing doesn't matter. The pad numbering scheme is continuous. From start value, columns, stagger type, columns, numbering start, 1. Let's try. Let's see how that looks like. This is wrong. Okay. Create array, so rows. Oh, I see. You know what? It doesn't really matter. 1, 2, 3, 4, 5, 6, 7. So what we can do now is, how was that? Name pads. There was a tool for that. Tools. Renumber pads. Renumber pads. Name prefix, first part number is 1, so we do 1, 2. Is that the correct order, actually? Because no, it's not. It's actually the other way around. So renumber pads, 1, okay, and 1 is actually here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 14. Enter. 14. How does it? Double click? Yeah, there we go. Okay, so that's good. Now we can move this to the side by, we need the right grid. 1.27 grid. 1.27. And move these like that. So now they are offset. Good. Okay, so let's check that the position is correct. 511. Yes. Okay. So that's done. Now we can put the mechanical to be soldered using paste-in-hole technology. Ah, interesting. If we look in here, it says to be soldered using paste-in-hole technology. Is there like a documentation somewhere? Do you basically keep the stencil open for the hole and just shove in some solder paste into the hole? Maybe that's what it is. Interesting. So you don't need to manually come in there and solder these in by hand. That is very cool. I like that. So we need to make those pads though, and give them some number. So, or they should not have a number, they should be just free floating. Yeah, we will see. Anyways, so let's put the pad in and the position. So one pad is here, and this shouldn't have a number. It should be through hole, circular, 0.84, 84, and then we can add like 1 millimeter maybe? Yeah, maybe more. Yeah, I'm curious, it doesn't say what the annular ring should be on those pads. They never do. It would be nice if they did. I have 15, not 14 on the pinout. Yes, I do. That's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. Come on. Seriously? You can do this. Ha ha ha. This is annoying. Thank you, Chrono T, for spotting that. There we go. Now it's correct. Do we have the library selected so I can save at least the progress I have now? Let's save this. And this goes into Samtech library. Yes, good. So, let's go back. So 8.4. Paste in hole technology, yes. Pad, pad, pad. So the position should be half. So let's see if that works, because this is a new feature in KiCad. It says position of the hole is number of positions. So we have 7 times 1.27 plus 3.91, and this whole thing divided by 2. By 2, because we're in the center. Perfect, there we go. So this is a new feature in KiCad. You can put in formulas in these fields, and it will calculate the resulting value for you. So you don't need to pull a calculator to get that. So in this case, if you look at on here, you see the position of this hole from the center line would be number of positions times 1.27 millimeters plus 3.91 millimeters. And because it's center line, we will divide it by 2. So that's what I did in the formula there. And 1.27, 3.91 divided by 2. There we go. And OK. And this is on this side. Good. Now, we want to put another one. Pad, duplicate, edit. Yeah, I will just copy it from here and do the minus. There we go. And the next one is the same, but it is offset by 2.26 down. I think I should add more area here. Let's add 0.2 here. That's better. There we go. That's better. And this should go south by 2.26. 2.26. Bam. Okay. Let's move this out of the way because we don't need it there. And we should also put in the outline and the board edge. So front of edge of PCB is here, so a fab. Let's do a line here. So maybe we should do a fab as a courtier, as an outline of the connector itself first. So this goes so C note 2, what is it saying? Connector envelope dimensions under components placed on PCB shall avoid this zone. Yes, so we will add the connector outline to this. Yeah, we fixed the pinout. It's like, sorry, I'm not as fast as reading your chats, but yeah, thank you for pointing it out. That's useful. Connector outline. So it is an additional, so 3.91. I still need a calculator here. Let me pull out, where's the calculator? It was in here. Ah, there it is. I got a new battery for my calculator. I'm very happy about that. So it is 3.91 added. So it is 6.88 minus 3.91, and this is 2.97 divided by 2. So it is 1.485. Jesus Christ, that's a that's an odd number. Jeez. But you can just go off from here, and it is 1.48 or just 1.5. Yeah, let's just do this. Let's round it up. And from here is 1.47, so another 1.5 for 5. Yes, enter. Let's draw this. And this goes for, so we should reset. I'm not sure this is visible on OBS. Yeah, so if you look in the right lower corner, It's like there, like, see, there, these numbers, I can reset them and make them relative to the position of my cursor. It's the distance. And this is 1.5 by 1.5. So yeah, that's what we are doing here. And I can use my arrow keys here to move this over. So let's reset that to 0 with space and then go down. Oh God, this is not working well. Let me, I moved this. Wait, the PDF moved. I did not want to do that. Okay, there, let's go to 0 position again. And how long is it? It goes for, oh, it's not far enough. I see it now. So actually, it is offset from here by 1.5, and from the edge of the connector, Jesus. People, this is ridiculous. Okay, so this goes from here to the other corner, 9.3. Yes, 9.3 north. 9.3, 2, 5, 6, 7. Come on. 9.3. There we go. So 9.3, and then we can go here. Is that on the center there? Yes. Space, and then 1.5 this way. There we go. Now, how long is that distance here? So it's 4.72 from the top one. Jesus Christ. From here to the edge here, it is 4.72, so 4.7. Then how wide is it? Does it show? Yeah, this drawing, the measurements on it are useless. Really annoying. Annoying. Okay, so from here we go 0.69 divided by, so it's 0.45. Yeah, 0.6. No, this one. This is position -1. No, it's position, so it is 1.2769. Okay, let's do this. 1.27. It's rattling. Sorry. Whoa. There we go. Times 7 plus 0.6969 divided by 2 is 4.79. So 4.8 in world coordinates. 4.8, there we go. And then we can go to the edge here, because that's what basically it says is the end of it. Correct? Yeah. Okay. Let's draw this. Now we can draw this guy. There. There we go. Just here. Then, what did we say? 4.8, yes? 4.78 down to here. Okay, finally we have the outline of this. Now we can put in also the PCB edge. I wish one could create dashed lines on the fab layer, but that will come eventually. Okay, so this guy is a line that is 1.47 from here, 1.47, 1.4, so 1.5 basically. Let's create a line like this. So that would be the PCB edge. There we go. There we go. Okay, cool. We should also create a courtyard while we are already at it, and this should be, usually it is 0.25 millimeters around the outline of a part, so we will do that. So 2.5 would be, or 2.3. Let's go. Let's make it nice and accurate. From this outline, this is not that terrible. 2.5, 2.5. That's the courtyard outline. There we go. Come on. 2.5, 2.5. There we go. 2.5. 2.5. 2.5. 2.5. 2.5. 2.5. There we go. Okay, so I should extend the PCB line maybe, or we make it just shorter so that it is more visible, that it is not belonging to the one. Yeah, let's do this. One like this. That should be clear. 2, 3. There we go. Bam. Okay. I think we are done on this. Nice new connector. So now we can go into the schematic. Come on, schematic, and then browse parts and put in TFM. There we go. TFM part. Good. Yeah. Now we can synchronize it. So this is also a new feature in current KiCad. I can just press F8 and then it will ask me to annotate and update the PCB and close. And then look at that. Bam! It's all updated. Where is the part? Where did the part go? Oh, there it is. Is that the part? Where's the footprint? Jesus. There we go. That's the footprint. There we go. It was offset. So we need more space on the board, I think. The interesting part will be, oh yeah, we can get the trace between the pads there, I think. Okay, cool. Like this. So we need to add a little bit PCB area to all this. And we can remove the silkscreen legend on here because this is not very relevant at the moment. So we will do this for now. Yeah, we have to like figure out how to add it back in. This is the new connection here. I have clock. That's very nice. Yeah, we should swap it. Trigger. Yeah, we should remove these traces here because this is not correct anymore. Yeah, track. Yeah, the delete button now deletes the whole trace, which is so nice. Yeah, like the improvements of the KiCad nightly build are so nice. Every time upgrading to a new version is a treat. Yeah, we have this SDASCL. Oh, that's the flash. That's the EEPROM chip that we were considering maybe getting a smaller one or something. But yeah, we will still not be able to squeeze it in. We have to make the board a little bit larger. It's not a big deal. So let's just do that. Yeah, let's just select this. PCB graphic. Let's unselect this. All right, now I'm going to do this and move. I think this is this line. Is it? You know what? This is in the way. Yeah, let's move this out of the way for now. Graphic. Yeah, and we want this line. So the first one, move, and bam. So now it is aligned. Now we can extend the cutout. Yeah, I will have to also download the step file for the connector from the Samtec website. That is also a nice thing that we can do. Let's extend the zone outlines. Zone outline. And zone outline. There we go. Yeah. Close the door here. Okay. And it's that 0.5. There we go. So this is not correct anymore. These are swapped. I think, yeah, we swapped these. Yeah, now that we are using this connector, I'm not sure this actually makes any sense to do. Anyways, I will just leave it. Yes. Is that correct? Yep. And then this. Yeah, and we will have to add the additional pin here. But that will, let's try this. Will that work? Yep. Then we can move it as a legend. Yeah, we have to pretty much do this. And then this guy. What is the pitch between these? I don't even remember. Let's copy this. Now duplicate. That work? Yes. Let's see. 1, 2, 3, 4. Yeah, we can measure it like this. That's easier. 1.3, okay. So 1.3 the other way. 1.3, there we go. And then move this guy. And this should be an I for IF clock, I guess. And this one has nothing because it's not connected at the moment. It's reserved. Okay, so now this probably should get like 2 letters next to each other to designate what is what. Yeah, I'm not sure this is useful. I will just delete it for now. I don't think we need this. The value, let's move that away. These are actually completely useless because this is pretty clear what goes on there. So let's do this, and invisible, and invisible. There we go, and this guy will be, what happened here? Edit, and lock footprint so that it doesn't fly away, or I don't move it by accident, pretty much. And we can now put this back in. And have the 60 millimeters in here. Very good. Yeah, so this connector is pretty much aligned with the PCB. The PCB is just it's pretty much exactly on the edge of the board. That is cool. I like that. So this connector is perfect for this board by coincidence. So now we have to, can we do this? Will that work? Ugh. So, is that correct? Yeah, it is correct. Because this one goes on the lower pins and this one goes on the higher pins. So the numbering is correct. We don't want to swap them. And then we have the grounds. We probably want to add, so another feature from the new KiCad, free floating vias, ground, stitching, perfect, without having to like make weird random traces all over the board. So we have ground connected. And what did I say? I said that we should have the trigger swap positions with IF clock. Yeah, IF clock. We still have to route out the IF clock somehow. So let's move this guy first out here. Let's make some space. Then do this, add a new connection here. Let's see how that looks. Yeah. Or yeah, we can actually go next to this guy. That was easier than I expected. Yeah, let's leave this here for now. Swap these two. So we want the first unit swapped the position with the second unit. So it is trigger changes position with IF clock. Move, move, come on. Come on, move, I said. Okay, and then F8, update PCB, boom, done. I have clock and trigger. So trigger, yeah, that's the annoying part. Yeah, so we will go, let's go to top layer. Let's do this like that, and then do this and that. Then we have I have clock. It's like, come on. There we go. Then we have trigger. Trigger and clock. Bam. Ground should connect by itself. Let's check. Yep, it's connecting by itself. Very nice. Then we have PB7. PB6. PB5. Come on, don't do that. PB4. PB3. That's nicer. PB2. Like this. PB1. Let's move this a little bit away. And PB0, this one we'll have to finagle out of here a little bit, like this. Yeah, let's make it a little bit nicer, more edges, longer stretches. There we go. Okay. Okay, this, I don't like that. I want it to go like this and move this. Good, good, good. All right, so that's done. There is some confusion in here. What's going on here? Why is this confused? 3.3 volt. Yeah, there is some reconnection of signals in here for some reason. I don't remember why. So reset was changed. I think I changed reset to get a pull down. I think there was a mistake here with the reset. It was not correctly connected. So 1 microfarad to ground to stabilize the reset pin and still pull it up. Okay, then, yeah, let's rotate this guy and move the 1 micro over. Yep, it's the label, and then do this. That's connected. Then, oh, I inverted the 3.3 volt connection. Ah, now I remember. Okay, so Uwe changed that in the firmware to invert this. And we actually changed something in the FX, so in the logic analyzer firmware. You're developing OCD. Let's see, what is the G that you're complaining about? Oh, the single G? Yes, delete, it's gone, just for you. Yeah, I can relate to this. So another OCD thing, this should be version 0.3, because that's what the version is. bottom silk screen, there's probably a version number that is wrong too. I completely forgot about fixing this. Version 2.0, that's not correct. 0.3. Okay. And in here probably is wrong. Yes, this is 3. There we go. So that's fixed. We got the signals out. Yeah, the IF clock will be fun because the IF clock is now like running all over the PCB to the other end here. Yeah, that's not ideal. And it's next to the trigger line too. So good luck with that. We definitely will have to test this. So yeah, there will be some coupling between those two. That's not pleasant. But yeah, we have to see how that works out. The IF clock line actually is meant to be used to clock in data into the FX2 chip in cases where you have slow signals with arbitrary timing between them. So that shouldn't be too hard, but we will see. Let's try it out. So anyways, let's going back to the topic of what we changed with the LED. In the FX2LA firmware for Sigrok, to be compatible with pull-up or pull-down LEDs, we actually wanted to check the value on the pin before we start driving it. So the firmware should be compatible with any of the devices without actually modification. But I wanted to use this circuit because usually chips are better at sinking power than providing power. So it's just good style to have it connected this way and not the other way around. So there we go. We want to add a 3.3 volt via and the signal, so we can actually rotate this bugger and move the green there. Let's move it to the top. Let's connect this here, and we can connect it to 3.3 volts here or give it its own via. Let's give it its own via. Let's be nice. There we go. Yeah, so let's see. One unconnected. Who are you? There is one unconnected. Page up. So there is a ground that is unconnected. How did that happen? Oh, this is lingering around here. So let's add a via here. Like this. That should do the job. Yeah, so 0 unconnected. Perfect, very nice. Okay, so I think we are done with the version 0.3, unless we missed something. So I will check that in and post it on Twitter and see if anyone has some additional input. The most important thing is to find the cables, which shouldn't be too hard. It's like I just have to order some samples from Samtec. So I will get some of those connectors, get some of these wires, and probably place the order for the next prototype run. So I think we are getting pretty close. If you have some better suggestions how to do the connections on this board, where we are not increasing the size of the board, we are using fairly off-the-shelf connectors. We can get discrete wires to make the fly wires like this to connect to clips. Then please let me know. I'm looking forward to hear your suggestions on this. And yeah, I think we're done for today. It's like, I don't even know how long the stream was, but it wasn't too long, I guess. How long are we? Are we on? Is there a timer somewhere? Yeah, it's 2 hours. It's not that bad. But yeah, I think we're good for today. I will try to keep the streams at least once a week, so that we have some reasonable pace on things. Next time, we will probably be working on either the some assembly of PCB, or maybe we will continue working on the FX on the logic analyzer with an FPGA in it, which we were working on too. I would like to finalize that design and get some prototypes done. Yeah, there's, as always, plenty of projects, and we should do that. I almost forgot, but I shouldn't. I would like to thank all the Patreons that are supporting this stream. It wouldn't be happening without them. Especially I would like to thank Kate Temkin, Keen Measles, Bob Miller, Garrett Kelly, and since last week also James Neal, who are all donating $5 or more to the channel. It's like every cent counts. It really helps with making prototypes, ordering odd parts, or even assembling stuff that is just a fun project, like the great good watch that we will be working on at some point. It's like I have all the parts, but I have to schedule that into these streams, and we will do that. Anyways, thank you so much for supporting this channel, and I will talk to you soon and see you here on the interwebs, and good hacking. And if you have been, thank you for watching.